Hi there once again and welcome to another Expresso Mechanic tutorial. And in this one we're going to be creating this, which is a kind of head-up display type affair. In order to achieve this we're going to be using some Expresso, a little bit of Python, and we'll also make use of a MoGraph Tracer. So without further ado, let's see if we can make this happen. The first thing I'm going to do is bring in a sphere. And we'll make this 20 in the radius, give it 40 segments, and we'll make it an icosahedron. For no other reason than I feel like making it an icosahedron. But that gives us our sphere. I'll also bring in a null object, and I'm going to call this Expresso. And initially, I'm going to just zoom out a little bit from here. So just a little bit. We'll give the Expresso a programming tag, so come down to Expresso and give it that tag. I'll bring the sphere in and I'll go down to coordinates, position, position X for now. So I've got that in. The next thing to bring in will be a time node. Bring one of those in, and once again I'm going to remove the time port and add a frame port. And then the next thing to do is bring in a range mapper. So we'll come down to calculate, range mapper. And we're going to need two of these, but for now we'll just bring in one, and I'm going to plumb the frame output into the range mapper's input there and plug the output into the position X of the sphere. Now, in the input lower here, what I'm going to do is say 60 in there, and in the output upper, 300. So let's see what that gives us. I'm also going to change my frames here. I'm going to make this 600, and you'll see why a little later. Let's see what happens. Okay, so my sphere is moving, but it's not repeating itself, which is what I needed to do. After 60 frames, I needed to go back to the beginning. So if I put a modulo in there and we play this, it starts to repeat, which is what we need it to do. So that's working okay, but it could do with an easing out curve. So in this spline here, I'm just going to create a point and create another point. Make sure they're in correct positions. Now let's just open our tangents, just twirl that down and see where we are. Yeah, the first tangent is at 0.25. This one over here, we just need to make that the same. So minus 0.25. And that's fine, that's ready to go. So let's just move this window out of the way and we'll shut it down for a minute and see where we are. And now we've got an ease out, ease in. And that's nice, that's doing what I wanted to. Great. So moving on from here, I'm going to bring in a plane object and I'll leave its orientation at +y. I'll make it 300 by 300 and its segments I want 6 by 6. If we just change to our garage shading lines display here, that's fine. That looks good to me. I mean, by all means, if you don't agree, change it. You can easily change the number of segments if you wish. The plane we will move, if we just go into coordinates, we will move it along its x-axis 150. And if we now play, we'll find that our sphere lines up perfectly. That's fine. That's what we're looking for. So let's create a second plane. It's just command drag to do that. And the orientation of this one will make +z. So now we have two planes that are ready to make the elements for our heads-up display. If we select both of them and make them editable, we can then select edge mode, select an edge on both of our planes, select all, so Command A for select all, and then we can come into our mesh here and say edge to spline. And now both of our planes have got splines within them. So that's great, that's what we want. So let's just remove that one. In fact, we need to select both and just remove them. We'll group these two and just say original planes in case we want to change anything, and then make them disappear. Great, so we've got our two splines there. What I'll do, I'll just select the both of them, and in my basic tab I'll change my display color to automatic and make it an orange sort of color. That'll do nicely, I think, for that. So that's done that, and now they're going to be orange all the time. Well, that's great, so that's fine. What I'll do is just make them disappear for a minute. Change my display back to Garrod shading. I'll also change the colour of my sphere. I think I'll make that green. So if we just give this a nice green colour, somewhere like that, that'll be fine. And now we're ready for the next step, which is to bring in a math modulo for a start. So we'll come down to calculate math, and we've got our node in. We just need to change its function to a modulo. We'll plumb in the frame output into the top input there, into input number 1, and change the value in input 2 to 60. So once again, we want every 60 frames, we want something to happen. Moving on from here, we need to bring in a flip-flop. So we'll grab a hold of one of those and plumb the output of the modulo into the switch, which is going to make our flip-flop flip and flop. It's going to activate it at the right times. So we're either going to be outputting a 0 or a 1, and that's going to enable us to do what we want to do. Moving on from here, the next thing we must do is bridge the gap between the flip-flop and the sphere, because we've got to work with the sphere's X position, Y position and Z position. So it's not just the X that we're interested in. So let's just go into coordinates and say position Y and position Z. We'll get those in so they're ready to use when the time comes. And then we'll think about how we're going to bridge this gap between the flip-flop and these two inputs here. We'll start by holding down our command key and grabbing a hold of this and copying it. And I'm also going to add a spline input. Now, if you've seen my tutorial on using the spline input for the range mapper, then you'll know, or at least have an idea of what I'm going to do here. If you haven't, well, you could always give it a look. It's probably worth having a quick look at it. But anyway, we'll move on from here. So we've got the spline input ready in our range mapper. Now, we've got to create two splines which we can feed this range mapper at the correct times. The flip-flop is going to control this. And in order to do it, what we're going to do is get a hold of a logic condition. We're going to place it here. We're going to place or plumb the output of the flip-flop into the switch. Leave that there. And we're going to sort out these two inputs. First thing we need to do is select spline for the data type, and that's given us two potential splines here. So the first spline, what I'm going to do is create 4 points. So 2, 3, 4. I'm going to place this one at 1 in the Y and 0.33 along the X-axis. This one needs to be 0 in the Y and 0.66 along the axis. What I've also got to do is place this one at 0.5 on the Y and this one at 0.5 on the Y. and then we can start working with our tangents. Let's have a look at what we've got here. 0.83, we don't really want that. We want something like minus point. Let's see what 2.5 looks like. Bit too much, I think, so let's go 1.25. Probably looks more like it. What have we got here? Yeah, again, we can say minus 0.125, I think, in there. That should be quite nice. And up here, we've got 1.25. What have we got here? We've got 1.25. And here, we need 1.25. 0.125. And that should work. I think that should work okay for us. That looks quite nice. Yeah, it looks pretty plausible that that's going to work out okay. So that's our first spline. Moving on to our second, we need a few more points. I'm going to do something different with this one. So we'll start again at 0 on the X, and we'll go to 0.5 on the Y. Create another point, and we'll make this one 0.2. Create another one, bring this down and make it 0.4. Another one which we will make 0.6 in the X, 0.6, and of course 1 in the Y. Another one at 0.8 in the X, and 0 on the Y. And then finally another point which we will place at the end of their graph there, and we'll make this 0.5 in the Y, and of course 1 in the X. So that's all fine. And now we'll look at our tangents again, and we'll make them, I think we'll go minus 0.125. See what we've got there. Minus 0.125. Yeah, I think this is going to work okay for us. Oops, don't want that. Minus 0.125. Just keep repeating it, basically, minus 0.125. That one's already done. And that one just needs to be 0.125. Okay, so that's great. So we've got two splines set up, and they're both different, and they're going to give us different results. That's great, that's what I want. And we can feed the output into the spline input of the range mapper, and we're okay there. But there's one more thing we need to do before we bridge the gap between the range mapper and these two. And we're going to do that next, and that's going to involve a little bit of Python. But before we start working with the Python, there's a couple of things I need to do with the range mapper. The first, we've just got to change the output range. So it's going to be minus 150 to 150. And we also need to get our frame port and plumb it into the input there to give us our input and something to work with. So, okay, that's great. Now we can start thinking about doing some Python. So if we come down to script, Python, the top input, if we have a look at the port information, we've got a real value. In fact, all of them are real values. But the first one I do want to be a real value, so I'll leave that as it is, and I'll just rename it and call this range underscore in. My second input I'm going to remove because I need to replace it with a bool. So I'm going to add a bool, and I'm going to call this bool, surprisingly. Yeah, we'll just call that bool. It's going to be coming from the flip-flop here because we're going to get a 0 or a 1, so that's perfect for that. And the range mapper's output can go into the range in. Our output here, we need another one, so we'll just add a second one, and they can both be floats because they're going to be controlling the X and Z positions. And we'll rename them, or rather the Y and Z positions, I beg your pardon, and we'll rename them Y and Z. So our Python node is now set up and ready to go. We might as well switch to a scripting layout. Actually, we'll do that, and we'll see where we go from there. Now, what we'll do, if we just go into Python node here. Just shut that down and open in editor. Okay, so we're ready to go. We can say global Z because we've got the Y's already in there. We just need to add the global Z. And then we can say if bool is equal to 0, Y is equal to range in, else Y equals 0. If bool is equal to 1, Z equals range underscore in, else Z is equal to 0. And that's as much as we need to do with Python. That we don't need to do any more. It's really very, very simple on this occasion, the Python that we've got here. So all we want to know, if we just bring this in. So if our flip-flop is giving us a value of 0, then we want to work with the range, or we want the range mapper, what's coming out of the range mapper, to be fed to position Y. If we're getting a 1 out of the flip-flop, whatever's being fed into the range mapper, we need to feed to position Z. That's all we're doing here. It's that simple. Okay, so let's hit the execute button and everything appears to be okay. We don't appear to have any errors, and we'll shut this down and we'll see what happens. Right, so range in is not defined. Let's have a look. Let's have a look and see what's going on. It's just one thing it's not liking. Range in is not defined. That's very interesting. Why is that not defined? Certainly should be defined. Let's just click on the Python and just have a quick look at what's going on in there. Where are we? Line 10. Oh, I see. Ah, it's a typo. Okay. So that. Okay, let's execute that. Just play the timeline. I'll tell you what, let's come out of the scripting layout and go back into the standard layout. Let's just play that and see what happens now. Ah, there you go. Now it's working. And you can see it's behaving as we wish. So we're getting 2 different behaviors, 1 per cycle, and a cycle is 60 seconds in length. Great, so that's working perfectly well. That's doing what we want it to. So let's bring back the Expresso. That's all good so far. Right, so far so good. That's doing what we want it to. Now what we can do is think about utilizing our planes and bringing those in, because we're going to make them change at the correct points so that we move our sphere along the XZ plane or the XY plane, depending on which cycle we happen to currently be on. Before I bring those planes in though, what I'll do, I'll just get rid of this for now. I'll make them visible, but what we'll do, in fact I'll just make one of them visible, it makes it easier that way. Just work with this one first. What we're going to do here is just make the things visible, because of course if we render this, they're just splines, so they don't render. I mean, of course you can put a hair material on them and work with those if you wish to, but what I'm going to do is bring in a circle, just drop it down there, make its radius 0.5, and then hold down my Alt key and get a hold of a sweep and drop it into there, and then put my plane under it. And now we're getting something that's going to be visible. I just need to change the material color or display color. Just make it orange. Something like that, that'll do nicely. Great, okay, that's fine. And then I just need to do the same for this plane here. So I'll copy my circle, hold down my Alt key again, drop it into a sweep, and then do the same thing again. And the same thing with the material color. What I'll do, in fact, go into there, hold down my control key, copy that color, set this up the same, and then hold down my control key again and paste that in there. Great, all done. So that's taken care of that, and what I'll call this one is the XZ grid, and this one will be the XY grid. So they're named and ready. We can just fold those up, bring the Expresso back, and now we can think about bringing these in. So we'll get a hold of both of them, drop them in here. And what we need to do is work with their basic properties, visible in editor, and we'll also put visible in renderer in there too. Just bring those two in there, and the same here. So they're now set up, and we're going to, our flip-flop can change their display statuses. We also need to bring in a not. So we'll come down to bool not, because when one is being displayed, the other needs to be switched off, and we need the not to be able to make that happen. So we can plumb that into there, plumb this into here and into here, and the outputs of the not can be plumbed into these. Okay, so let's see what's happening, and let's see if it matches up. If it doesn't, we just need to swap them round. No, that's fine. Yep, that's working perfectly. Great. Exactly what we wanted to see. Just to finish this off, we'll give the sphere a tail, a bit like a comet, which will trace the path that it's following. That'll give it a nice sort of look for the final render. In order to do that, what we'll do first is bring in a null object. I'll just reset my timeline to 0 so that our null and our sphere are matching up, and then I can simply drop that in there, and I'll just call this target. That will do for that. That's our tracer's target. And then moving on from here, we can bring in a MoGraph Tracer. So we'll get one of those. Just drop it down under there. And I'll bring a circle in, because we will want to make this part of a sweep. So we're going to put both of them into a sweep. So I'll hold down my Alt key and get a hold of one of those. Bring that in there, and we'll drop the tracer in as well. And the circle, we will give a radius of just 2 centimeters, and we can leave it set up in the XY plane. That's fine. So that's set that up so far, and we can now think about what we're going to be doing with the tracer and possibly the sweep. So in the sweep, we can leave everything up here the same. We don't need to change anything. We can just turn these off. We don't need them. Banking and constant cross section we will leave on. In our details here, we just need to work with the scale, and we can just bring this down to the bottom. That's all we need to do there, and that way our tail will scale down to nothing as it falls away from the sphere. That's all we need to do there. So the sweep is all nicely set up, and now we can worry about playing around with the tracer. Now the target's already in the trace link, which is fine. That's what we want. We don't need to use TP subgroup, so we can turn that off. We can leave these two on. The sample step we'll leave as 1, and trace paths in the tracing mode is fine. Okay, that's all good. We'll leave this at global. We can leave this as nodes only. That should be fine for us there. The type I'm going to make cubic for the spline. Okay, that's all looking good. And we'll say from end, and we'll give an amount of, let's try 15. We'll leave that as the amount in there. Intermediate points, we'll say, let's have a look. We could go subdivided, or we can go uniform. Actually, will probably be all right, and put 20 in there. I think 20 will be fine for the number of points. We'll leave that as it is. Okay. Right, I think we're ready to at least have a go at this. Let's see what's happening. Yeah. Yeah, that's looking nice. It's tracing okay. There's a bit of a glitch in it when it comes to the end, which we're going to sort out in a minute, but that looks quite good. I'm thinking that that looks good. Yeah, that works, doesn't it? Okay, so let's just stop that. One thing we will do, of course, is change the color of the sweep. So if we go into our basic here, let's go into automatic and we'll give this, what should we give it? I don't know. Let's give it a sort of a pinky color. That'll be quite good, maybe. Something like that. Let's see what that looks like. We may change things, of course, if we wish to. Well, that's okay. I'll tell you what we'll do. I'll change this to green. Just change that to a green colour. And I'll change the colour of the sphere to maybe a purple. I think that's what I did in the original. Let's just see where we are here. Let's just get that, see if we can get a kind of a purple in there, that sort of colour. Yeah, perhaps a little bit too dark. Let's go a little bit brighter. That's okay. Right, let's just see what that looks like. Yeah, I prefer that actually. That colour combination works better, I think. But it's entirely up to you. You can, of course, change it to whatever you desire. Okay, that's great. That's great. Now, that glitch that appears in it, if we just play this, there, you can see that the tracer is still tracing across here. We don't want that, and we can actually fix it quite easily. So if we go into our Expresso again, and we bring in the tracer, what we can do is come down into the object properties here, and we can select trace active. And what we're going to do is switch the tracer off and on at the points that we need to stop that glitch from happening. And the way we're going to do that is to plumb in the output from this modulo into there. And let's see what happens now. And there you go. It's fixed it. And that doesn't happen anymore. It does finish itself off, but that's kind of okay. It gives it a bit of character. But that horrible glitch is now gone. And that is how you go about creating a heads-up display with Expresso, a little bit of Python, and a MoGraph Tracer. And that about wraps this one up. So as always, I hope you've enjoyed this tutorial and it's been worthwhile doing it and you've learned a little bit more. And if you have enjoyed it, then please give the video a thumbs up. And if you haven't already, then please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, then please share the video, because all of this good stuff helps to keep the channel going in the right direction. But anyway, that brings the curtain down on this one. So I'll see you very shortly on the next tutorial.